Assalamualaikum and hi everyone. We are going to present about topic applied maximum and minimum in real life under the chapter of differentiation. So let's get started.
초능력처럼 거대한 자석이 된 것만 같아 my heart 네 모든 게 내 맘에 달라붙어 버려 girl We magnetized 인정할게.
First, we are going to explain about what is differentiation. Differentiation, it can be defined as a derivative of a function with respect to an independent variable. It also can be applied to measure the function per unit change in the independent variable. We apply when to determine increasing or decreasing of a function, speed or distance of moving objects, and to find the maximum and minimum values of a particular function.
This time I want you.
So now we move to the applied maximum and minimum in real life. So first, we have to know what is maximum and minimum. Maximum and minimum is the process of finding maximum and minimum values is called optimization. For example, maximize the profit in the company or minimize the cost or find the least amount of material to make a particular object. So now, why we need to learn this? We need to learn this is to increase understanding about application of differentiation. Second is to understand how to apply maximum and minimum problems. Third is to be able to solve the question by using the suitable formula.
Next, the things that we use to apply maximum and minimum is cylinder box. The introduction of cylinder box is Elena got a present from her mother on her birthday. The gift was a cylindrical lunch boxes as shown in the diagram. The radius of cylinder is x and height is y.
We move to the problem statement. As you can see, the diagram that I draw is circle and rectangle. So from the circle, we need to find the radius, which is x, and from the rectangle, which is this, and we need to find the height, which is y. So problem statement number 1 is if the surface area of the cylinder is 216 pi, write y in terms of x. Second is prove that the volume of the cylinder is V equal to 108 pi x minus pi. Third is find the dimension of the cylinder such that the volume is maximum. Fourth is determine the maximum volume in pi.
So question A is if the surface area of the cylinder is 216 pi cm square, write y in terms of x. So first thing first, we are going to find the area of cylinder. The area is given, which is 216 pi. So we just substitute the value into the formula and we get 216 pi equal to 2 pi r square plus 2 pi r h. So remind that x is equal to the radius, y is the height. So we calculate and we get 2 pi x y equal to 216 pi minus 2 pi x square. So y equal to 216 pi minus 2 pi x square over 2 pi x. So 216 pi over 2 pi x, we get 108 over x. 2 pi x square over 2 pi x, we can cancel out and then we get x. The final answer is we get y equal to 108 over x minus x.
For question B, we need to prove that the volume of cylinder is 108 pi x minus pi x cubed. Firstly, we need to know the volume of cylinder. The volume of cylinder is V equal pi r square h. Then we substitute the value of r and h. So V equal pi x square y. Next, V equal pi x squared times 108 over x minus x. 108 over x minus x, we got from question A that we got y equal 108 over x minus x. After that, we can do multiplication of the equation. So, V equal 108 pi x squared over x minus pi x cubed. Then, we can simplify the equation. So, we got the answer V equal 108 pi x minus pi x cubed.
The solution or calculation for problem statement number 3 is the equation of volume is 108 pi x minus pi x cube. So we need to differentiate the volume, which is dv over dx equal to 108 pi minus 3 pi x squared. So let dv over dx equal to 0, so that 108 pi minus 3 pi x squared equal to 0. So it will become negative 3 pi x squared equal to negative 10x pi. So x squared equal to negative 108 pi over negative 3 pi. So x squared equal to 36 and x is 6 cm, which is the radius. So we need to know the value of x is the maximum or minimum. So we need to the value of x into the second derivative. So it will become negative 6 pi times 4 times 6 equal to negative 36 pi. So it's 36 pi is less than 0. So x which is radius equal to 6 cm is the maximum value. So next we need to find the value of y, which is the height. So the equation of y is 108 over x minus x. It will become 1, so we need to substitute the value of 6 into the equation. So 108 over 6 minus 6, it will become 12 cm. So the height of the cylinder box is 12 cm.
Lastly, for question D, we need to determine the maximum value in pi. So, V equal 108 pi x minus pi x cubed. That equation we have just got from question B. After that, we substitute the value of x that we have got from question C, which is 6. So, V equal 108 times 6 pi minus pi times 6 cube. Finally, we got the answer is V equal 432 pi cm cube.
Next, to sum up, first we can find the area and the volume of the cylinder.
Next, we know how to find radius and height of cylinder from first derivative. And lastly, we can identify the right formula, and accomplishing both first and second derivatives correctly will lead to a solid answer, a maximum or a minimum volume. So that's all from us. Bye!
This time I want you, like it's magnetic.